All right, so in this video, we're going to look at solving a compound inequality. What that means is you've got two inequalities happening at the same time, and whatever x value you pick, it needs to satisfy like the entire statement as a whole. All right, so let me show you how to do it. It's not too bad. You just solve each inequality independently of the other. So the one on the left-hand side, I'll solve that first. I'm just going to divide by -8. So that's going to give me x is greater than or equal to -3. All right, and I flip that inequality because I divided by a negative. The one on the right, we'll add 5 to both sides. That's going to give me x is less than 7. Okay. And then don't forget about this middle word here, all right? This one is an and inequality. So if I read these, it says here that x has to be greater than -3 and it has to be less than 7. All right, so hopefully you can picture those numbers in your mind. Numbers that are bigger than -3 and less than 7 are going to be numbers like 6, 5, 4, 3, 2, 1, 0, -1, and -2. Okay, so it has to satisfy both halves of this inequality in order to make sense. As far as graphing it goes, you got your number line as usual, and you just put the right kind of dot at these endpoints. So here at 7, all right, I'm going to do an open dot, and because I want it to be less than 7, I'll go to the left, and then I'll do an open dot at -3 as well. And I want it to be greater than it, so I'm going to go to the right. And you'll see here that the two dots are connected whenever you have an and inequality. That's typically the way it's going to work out. Of course, there's exceptions, but in general, this is the way you do it. So you solve them both independently of the other, and then graph the solutions on the number line. All right, let's look at an or statement this time. All right, again, I'll just solve the one on the left and solve the one on the right. So the one on the left, I'll add 2 to both sides. That's going to leave me with 3/4 x is less than -8 plus 2 is -6. Okay, and then I'm going to get rid of this the fraction part. I'm going to multiply the whole thing by 4 to clear that denominator. So the 4s are just going to cancel each other out because you're multiplying by 4 and dividing by 4. So it's just going to leave me with a 3x on the left-hand side. And I'm not going to flip my symbol here because I didn't multiply or divide by a negative. On the right-hand side, 4 gets multiplied by the -6. So I get -24. Okay. And then you'll divide by 3 to cancel the 3. That leaves me with x is less than -8. Okay, save that one. Now this inequality on the right-hand side, a lot of people, what they like to do, because the variable is on the right, is they will flip this whole statement around. Instead of saying 5 is greater than or equal to 2 minus x, you could say that 2 minus x is less than or equal to 5. All right, I'm just flipping that entire statement around. That way I have my variable on the left-hand side. A lot of people just prefer to solve it like that. I'll do it both ways just to show you that they're equivalent. But what I'm going to do for this one on the left-hand side is I'm going to move my x over. So I'll add x to both sides. That's going to give me x plus 5 is greater than or equal to 2. And then I'm going to subtract 5 from both sides. -5 minus 5. That'll be x is greater than or equal to -3. Okay, get my OR statement in there. Now, if I had solved it based on this one over here on the right, I'm going to get the same answer. It's just, I guess, looks a little bit different. I'd move the 2 over first. That's going to leave me with a -x is less than 3. And then to cancel out the negative, I would divide by -1. And so -x divided by -1 just leaves me with an x, but I'd have to flip that inequality symbol, and then I'd get -3. So you see they are the exact same answer. All right. As far as the graph goes, let's go ahead and graph the solutions here. Zeros in the middle. Okay, so at -8, I'm going to have an open dot, and I want the numbers that are less than -8. That's what that says there, less than -8. So I would go to the left, and then for the other one, I'm going to do a closed dot at -3. All right, it's a closed dot because it's got that little bar underneath it right here. The or equal to means that you're going to include -3. And it's going to be going to the right. So on an OR statement or an OR inequality, the arrows will typically go in opposite directions of each other. Okay. So if I pick any number that is, shaded, I guess, so like 5, all right, if I use the number 5, it's going to satisfy the original statement up here. All right, it's going to make this one true, but it's going to make this one over here false, which is okay because it was an OR statement. Like I only had to satisfy either one of these in order for the entire thing to be counted as true. All right. But if I picked a number between -8 and -3, so like if I picked a number like -5 or -6, all right, it wouldn't satisfy either one of these inequalities. All right, both of them would have been false in the end, and so it wouldn't have been true. All right, that's how you solve a compound inequality.